If you were asked to name the planet most similar to Earth, many people would probably guess Mars. After all, Mars has mountains, valleys, polar ice caps, and the possibility that water once flowed across its surface. But the real answer might surprise you. The planet most like Earth is Venus. At least, that's how the story begins. Venus and Earth are nearly the same size. They have almost the same mass. Their gravity is remarkably similar. Both formed from the same cloud of gas and dust more than 4.5 billion years ago. For decades, scientists refer to Venus as Earth's twin. From a distance, it seemed reasonable. If Earth could become a world filled with oceans, continents, and life, why couldn't Venus? But somewhere in their shared history, their paths separated. Earth became a blue planet where life transformed the surface. Venus became a world hidden beneath thick clouds of sulfuric acid, a place where the surface is hot enough to melt lead, where the atmospheric pressure is so intense that a human would be crushed almost instantly, where a single day lasts longer than an entire year. How could two planets born so similar end up becoming complete opposites? The answer isn't just a story of Venus. It's one of the most important stories in planetary science, because understanding what happened to Venus may also help us understand why Earth remained habitable and how fragile that balance truly is. Today, we're traveling to the brightest planet in our night sky, a world once imagined as a tropical paradise that turned into the most hostile planet in the solar system. This is the story of Venus. Long before spacecraft ever visited Venus, the planet inspired endless speculation. Unlike most planets, Venus is impossible to miss. It's one of the brightest objects in the night sky, often shining so brilliantly that it can cast faint shadows under the right conditions. Ancient civilizations across the world watched it carefully. The Babylonians recorded its movements thousands of years ago. The Maya built parts of their calendar around its appearance. The Greeks originally believed the bright object seen before sunrise and the one visible after sunset were two different celestial bodies. Only later did astronomers realize they were observing the same planet, Venus. For thousands of years, no one knew what lay beneath its brilliant clouds. That mystery allowed imaginations to run wild. By the late 19th and early 20th centuries, many scientists believed Venus might be covered by vast oceans. The reasoning seemed simple. The planet was almost the same size as Earth. It appeared permanently wrapped in thick white clouds. Clouds on Earth are made from water. So perhaps Venus was simply a warmer version of our own planet. Some imagined endless tropical forests. Others envisioned shallow global seas stretching across the surface. Science fiction writers filled their stories with giant plants, mysterious swamps, and alien civilizations hidden beneath the clouds. Without direct observations, almost anything seemed possible. Venus became the solar system's greatest mystery. The idea wasn't entirely unreasonable. Modern measurements show that Venus and Earth are astonishingly similar in several important ways. Venus has about 95% of Earth's diameter. Its mass is roughly 81% of Earth's. Gravity at its surface is about 90% as strong as ours. If you stood on Venus, ignoring every other deadly problem, you would feel almost the same weight as you do on Earth. Even their internal structures appear surprisingly alike. Both planets had an iron-rich core surrounded by a rocky mantle and crust. Both formed in the inner solar system from the same population of rocky building blocks. In many ways, Venus wasn't simply Earth's neighbor. It was Earth's closest sibling. That raises an extraordinary question. How did two nearly identical planets end up becoming so different? The answer begins more than 4.5 billion years ago, during the violent birth of the solar system. Around a young sun, countless collisions gradually assembled the rocky planets. Earth and Venus likely formed under remarkably similar conditions. Both experienced enormous impacts. Both were covered by oceans of molten rock. Both released gases from volcanic activity, slowly creating their first atmospheres. For millions of years, the two worlds may have looked surprisingly alike. Neither resembled the planets we know today. Both were still evolving. As the young solar system cooled, water vapor in Earth's atmosphere condensed into rain. Over millions of years, that rain filled the first oceans. Those oceans transformed everything. Water absorbed carbon dioxide from the atmosphere. Plate tectonics recycled carbon into the planet's interior. Over time, Earth's atmosphere became more stable. Eventually, life emerged. Then life began reshaping the atmosphere even further. Venus may have started with many of the same ingredients. Some computer simulations suggest early Venus could even have possessed shallow oceans for hundreds of millions, or perhaps even billions, of years. It's still an active area of research. No one knows exactly how much water early Venus had, but the possibility alone has changed how scientists think about the planet. Instead of asking whether Venus was always an inferno, they now ask when it stopped being one. The sun also plays an important role in this story. Venus orbits about 108 million kilometers from the sun. Earth, by comparison, orbits at nearly 150 million kilometers. That difference may not seem enormous, but it changes the amount of solar energy each planet receives. Venus is exposed to almost twice as much sunlight as Earth. At first, that extra energy may not have been enough to completely transform the planet, but over immense spans of time, small differences can produce enormous consequences. Planetary evolution isn't usually driven by a single catastrophic event. It's often shaped by tiny advantages or disadvantages that accumulate over billions of years. Venus may be the ultimate example. As scientists studied Earth and Venus together, they began noticing something important. Habitability isn't determined by size alone, or mass, or even distance from the sun. It's controlled by an intricate balance between geology, atmosphere, solar energy, and time. Earth remained within that balance. Venus gradually drifted away from it. The two planets became a natural experiment conducted over billions of years. One world remained capable of supporting oceans. The other lost them. One developed a stable climate. The other entered a cycle that would eventually transform the entire planet. Understanding that divergence has become one of the central goals of planetary science. Because if we can explain why Venus changed, we gain a deeper understanding of why Earth did not. By the middle of the 20th century, astronomers were eager to solve the mystery once and for all. Powerful telescopes still couldn't see through Venus's thick cloud cover. The surface remained completely hidden. The only way to discover the truth was to go there. The space age arrived at exactly the right moment. For the first time in human history, spacecraft would travel to another planet and send back direct measurements. Many scientists still hope Venus would reveal oceans, perhaps even environments capable of supporting life. Instead, the first probes uncovered something no one had expected. Not another Earth, but one of the most hostile environments ever discovered anywhere in the solar system. The planet humanity, once imagined as a paradise, would soon become known as Earth's greatest warning. When the first spacecraft approached Venus, scientists expected answers. What they found raised even bigger questions. The thick clouds surrounding the planet had hidden the truth for thousands of years. From Earth, Venus looked calm, bright, beautiful, almost peaceful. But beneath those clouds lay one of the most extreme environments ever discovered. The Soviet Union became the first nation to successfully send spacecraft into Venus's atmosphere. Beginning in the 1960s, the Venera program pushed engineering to its limits. One mission after another descended through the dense clouds, each surviving only a little longer than the last. The atmosphere proved far harsher than anyone had predicted. Pressure increased rapidly. Temperatures climbed relentlessly. Several spacecraft were crushed or destroyed before they could transmit meaningful data. Then, in 1970, Venera 7 achieved something extraordinary. For the first time in history, a spacecraft landed successfully on another planet and transmitted data back to Earth. The numbers shocked scientists. The surface temperature measured around 465 degrees Celsius, hot enough to melt lead. The atmospheric pressure reached approximately 92 times that of Earth. Standing on Venus would be like standing nearly 1 kilometer beneath Earth's oceans. Every expectation of a tropical paradise disappeared overnight. Venus wasn't Earth's twin anymore. It was something entirely different. The obvious question followed. Why? Mercury is closer to the sun than Venus. So why isn't Mercury the hottest planet? The answer lies not in distance, But in atmosphere, Mercury has almost no atmosphere at all. During the day, sunlight heats the surface intensely. At night, that heat escapes directly back into space. Venus behaves completely differently. Its atmosphere traps heat with extraordinary efficiency. More than 96% of the atmosphere consists of carbon dioxide, one of the most powerful greenhouse gases found in nature. Above it float thick clouds composed largely of sulfuric acid droplets. Together, these layers create a planetary blanket unlike anything else in the solar system. Sunlight enters. Heat struggles to escape. The result is an endless greenhouse effect operating on a global scale. On Earth, the greenhouse effect is essential. Without naturally occurring greenhouse gases, our planet would be a frozen world with an average temperature well below freezing. The atmosphere keeps enough heat trapped to allow liquid water and life to exist. Venus demonstrates what happens when that same process becomes uncontrollable. Scientists call it a runaway greenhouse effect. At some point in Venus's history, temperatures rose high enough for increasing amounts of water vapor to enter the atmosphere. Water vapor itself is also a greenhouse gas. More water vapor trapped more heat. More heat caused even more water to evaporate. The cycle fed itself. Eventually, the oceans, if they existed, could no longer remain stable. As temperatures continued rising, the planet crossed a threshold from which it could no longer recover. Without large oceans, another crucial process disappeared. On Earth, rainwater absorbs carbon dioxide from the atmosphere. That carbon becomes locked inside rocks and recycled into the planet's interior through plate tectonics. It's part of Earth's long-term climate regulation system. Venus appears to have lost that balance. Instead of removing carbon dioxide from the atmosphere, volcanoes continued adding more. Over immense periods of time, carbon dioxide accumulated until it dominated the atmosphere almost completely. Every additional molecule trapped even more heat. The cycle continued for millions of years. The planet became hotter and hotter until it reached the inferno we observe today. Despite these extreme conditions, Venus is surprisingly active. Radar observations have revealed a surface covered by enormous volcanic plains, towering mountains, and thousands of volcanic structures. For decades, scientists debated whether those volcanoes were ancient relics or still active today. Recent observations have strengthened the case that at least some of them remain active. Changes detected in volcanic vents suggest molten rock may still be reshaping portions of the surface. If confirmed, Venus would join Earth as one of the few rocky planets in the solar system with ongoing volcanic activity. That internal activity may continue feeding gases into the atmosphere even today. Venus isn't simply a world that changed long ago. It may still be evolving. The atmosphere itself behaves unlike anything on Earth. Although the solid planet rotates extremely slowly, its atmosphere races around it at astonishing speeds. A single rotation of Venus takes about 243 Earth days. Even more unusual, Venus rotates in the opposite direction of most planets. The sun would appear to rise in the west and set in the east. Yet high above the surface, powerful winds complete an entire trip around the planet in only about 4 Earth days. Scientists call this phenomenon superrotation. Exactly why the atmosphere moves so much faster than the planet beneath it remains one of Venus's greatest mysteries. Even after decades of research, no single explanation fully accounts for this remarkable behavior. The clouds hiding Venus are just as unusual. They're not made primarily of water. Instead, they're composed of tiny droplets of sulfuric acid. Fortunately, these clouds don't reach the surface. As sulfuric acid falls into the hotter lower atmosphere, it evaporates before ever touching the ground. Even so, the cloud layers create a chemically complex environment unlike any other planet. Sunlight interacts with gases high above the clouds, driving reactions that scientists are still trying to understand. Some of those reactions produce mysterious ultraviolet patterns visible only from space. Even today, researchers continue debating exactly what causes them. Venus refuses to give up its secrets easily. Then came one of the most controversial moments in modern planetary science. In 2020, a team of astronomers announced evidence suggesting the possible presence of phosphine in Venus's atmosphere. On Earth, Phosphine is associated primarily with biological activity or industrial processes. Its possible detection immediately sparked worldwide attention. Could something be producing phosphine high within Venus's clouds? Some scientists proposed unknown chemical reactions. Others questioned whether the signal had been detected correctly in the first place. Additional observations have produced conflicting results. Today, the debate remains unresolved. The phosphine controversy didn't prove life exists on Venus, but it accomplished something equally important. It reminded the scientific community that Venus still contains unanswered questions worth investigating. For many years after the Apollo era, Mars received most of the attention. Venus gradually faded into background. That trend is now changing. Modern missions are returning. NASA's DAVINCI mission aims to descend through Venus's atmosphere, measuring its composition in unprecedented detail. VERITAS will map the planet's surface with high-resolution radar, searching for signs of ongoing geological activity. Meanwhile, the European Space Agency's ENVISION mission will investigate how Venus's interior, surface, and atmosphere continue interacting today. Together, these missions seek answers that scientists have pursued for generations, not simply because Venus is fascinating, but because it may hold critical clues about the evolution of rocky planets everywhere in the universe. Perhaps the greatest lesson Venus offers is this: planetary evolution doesn't always move toward stability. Two planets can begin with remarkably similar ingredients, yet arrive at completely different destinations. One became a world of oceans. The other became a world where the atmosphere itself turned into a trap. Understanding exactly where their histories diverge remains one of the biggest challenges in planetary science, because somewhere within that answer may lie the explanation for why Earth became our home and why Venus became hell. For much of the late 20th century, Venus slowly faded into the background. The excitement shifted elsewhere. Mars became the center of attention. It offered dried-up river valleys, ancient lake beds, polar ice caps, and the possibility that life may once have existed there. Compared to Mars, Venus seemed almost hopeless. Its surface was far too hot, its atmosphere far too dense, its conditions far too hostile. If humanity wanted to understand habitable worlds, why spend time studying a planet that clearly wasn't one? For years, that question shaped the direction of planetary exploration. But today, the answer is changing. Scientists no longer study Venus because they expect to find cities beneath the clouds or civilizations hidden underground. They study Venus because it represents something even more valuable: a planetary experiment. Earth and Venus began with remarkably similar ingredients. Yet over billions of years, one remained habitable, while the other became almost unrecognizable. Somewhere in that divergence lies information that could reshape our understanding of rocky planets, not only within our solar system, but throughout the galaxy. Every year, astronomers discover hundreds of new exoplanets orbiting distant stars. Many are close in size to Earth. Some orbit within what scientists call the habitable zone. From a distance, several of them appear remarkably promising, but appearance alone can be deceptive. If Venus has taught us anything, it's that two planets can look nearly identical while hiding completely different realities. That lesson has become increasingly important in the era of exoplanet discovery. When astronomers detect a distant rocky planet, they often know only a few basic properties: its size, its mass, its orbit. Occasionally, they can begin studying its atmosphere. What they cannot see directly is the planet's history. Did it once have oceans? Did volcanic activity reshape its climate? Did a greenhouse effect spiral out of control? Or did it remain stable long enough for life to emerge? These questions are incredibly difficult to answer from hundreds or even thousands of light years away. Venus provides a nearby laboratory where scientists can test the models they use to interpret distant worlds. In many ways, understanding Venus is helping us understand planets we may never visit. The renewed interest in Venus has inspired a new generation of exploration. NASA's DAVINCI mission will descend to the atmosphere, directly sampling gases that have remained trapped for billions of years. Those measurements could reveal whether ancient Venus once possessed significantly more water than it does today. At nearly the same time, VERITAS will create the most detailed global radar maps ever produced of the planet's surface. Scientists hope to identify signs of recent volcanic activity, measure geological changes, and better understand how Venus releases heat from its interior. Meanwhile, the European Space Agency's ENVISION mission will investigate how the atmosphere, surface, and interior continue interacting as a single planetary system. Instead of asking isolated questions, these missions are designed to explain how Venus works as an entire world. One of the biggest mysteries still concerns water. Exactly how much did Venus lose? And when? Today, the atmosphere contains only tiny traces. But scientists have found important clues. Measurements show an unusually high ratio of deuterium, a heavier form of hydrogen. Because lighter hydrogen escapes into space more easily, an elevated deuterium ratio suggests that enormous amounts of ordinary hydrogen disappeared over time. Since water is made of hydrogen and oxygen, many researchers interpret this as evidence that Venus once possessed far more water than it does today. Whether those reserves formed shallow oceans, scattered seas, or something in between remains uncertain. But the evidence points toward a wetter past, one very different from the planet we see today. Venus also challenges another assumption. For decades, scientists believed plate tectonics might be essential for maintaining a stable climate. Earth constantly recycles carbon between the atmosphere, oceans, and interior. That process helps regulate atmospheric carbon dioxide over geological timescales. Venus appears to operate differently. Its surface shows no clear evidence of Earth's style of moving tectonic plates. Instead, heat may accumulate beneath the crust for immense periods before being released through widespread volcanic activity. If that's true, Venus demonstrates that rocky planets can evolve through multiple geological pathways. That realization is changing how scientists model the evolution of Earth-like planets across the universe. Then there's the atmosphere itself. Although the surface is unimaginably hostile, conditions become surprisingly different at higher altitudes, roughly 50 to 60 kilometers above the surface. Temperatures and pressures begin approaching values not entirely unlike those found on Earth. For decades, researchers have wondered whether these cloud layers might host unusual chemical processes. The controversial phosphine announcement brought renewed attention to this possibility. While no convincing evidence for life has emerged, the discussion highlighted an important point. Venus remains scientifically open. It is not a solved mystery. Every new observation has a potential to overturn assumptions that have existed for generations. Perhaps the greatest surprise is how often Venus appears in modern climate research. Scientists are careful not to describe Venus as Earth's inevitable future. The two planets are fundamentally different in important ways. Earth sits farther from the sun. Its oceans remain stable. Its atmosphere contains vastly lower concentrations of carbon dioxide. Its climate is regulated through multiple interacting systems. Even so, Venus demonstrates the immense power of greenhouse gases over geological timescales. It reminds us that planetary climates are not fixed forever. They evolve, sometimes gradually, sometimes dramatically. Understanding those processes helps researchers build more accurate models, not only for Earth, but for every rocky planet we discover. There's another reason Venus matters. One day, humanity may detect an Earth-sized planet orbiting another star. It may have the right temperature, the right size, the right orbit. From across the galaxy, it could look like another Earth. But until we understand why Venus changed, we can't confidently explain whether that distant world truly resembles our own. Every lesson learned from Venus improves our ability to recognize genuinely habitable planets. Ironically, one of the best ways to search for another Earth is to first understand why Earth's twin failed. More than 60 years after the first spacecraft reached Venus, the planet continues to challenge scientists. It has forced researchers to rethink atmospheric evolution, planetary geology, climate stability, volcanism, and even the search for life itself. Very few worlds have changed our understanding of planetary science so profoundly. Yet Venus still hides much of its history beneath clouds that no human eye has ever seen through directly. Its greatest discoveries may still lie ahead. For generations, Venus was simply the brightest planet in the evening sky, a brilliant point of light admired by ancient civilizations long before telescopes existed. Today, we know that behind those beautiful clouds lies one of the most extraordinary stories in the solar system. Not because Venus is the hottest planet, not because its atmosphere can crush a spacecraft, not because sulfuric acid fills its skies. Those are only consequences. The real story is far deeper. Venus teaches us that planets are not defined by how they begin. They are defined by how they evolve. Earth and Venus started their journey together. One became an oasis. The other became an inferno. Understanding why may be one of the most important scientific questions humanity will ever answer. Because somewhere inside the story of Venus is the story of our own planet, and perhaps the story of countless other worlds still waiting to be discovered. From Earth, Venus has always been a beacon in the sky. Beautiful, brilliant, almost inviting. But appearances can hide extraordinary truths. Sometimes, the planets that look most familiar have the most unexpected stories to tell. And in the case of Venus, that story may ultimately help us understand not only our nearest planetary neighbor, but our place among countless rocky worlds throughout the universe.